Good day, math buddies! Sir Sherwin here, your math instructor. Welcome to another content where we are learning all about mathematics in an exciting and interesting way. And for today's video, we will learn all about joint variation. Of course, we will be guided with these objectives, and these are: first, to define a joint variation. Second, we will translate statements into mathematical equation. Third, solve for the constant of variation. And fourth, solve word problems involving joint variation. But first, please don't forget to subscribe to my YouTube channel and hit the notification bell for more updated contents. And I will be more glad if you like this video, leave a comment, and share with friends. So let's start this math lesson now. Hello dear math buddies! Welcome to my YouTube channel and thank you for watching my content. As what we mentioned earlier, today we will learn all about joint variation, its definition, its equation, and its related word problem. And to start, let us have the definition of a joint variation. Joint variation describes a situation where one variable depends on two or more other variables and varies directly as each of them when the others are held constant. The mathematical statement that best represents a joint variation would be A varies jointly as B and C. And this statement can be written mathematically as A is equal to KBC, where K is the constant of variation. With this, join me as we translate some mathematical statements into equation. Let's have the first one. P varies jointly as Q and R. This statement can be written mathematically as P is equal to KQR, where K is the constant of variation. Again, P is equal to KQR. Second, P varies jointly as L, W, and H. So our equation can be written as P is equal to K, L, W, H. Again, K represents the constant of variation. Our equation would be V is equal to K, L, W, H. Let's have the third one. The area A of a triangle varies jointly to its base B and altitude H. So this can be written mathematically as A is equal to KBH, where K is the constant of variation. Again, A is equal to KBH. Let's have the fourth one. The electrical voltage V varies jointly as the current I and the resistance R. Mathematically, this statement can be written as V is equal to KIR, where K is the constant of variation. Again, V is equal to KIR. This time, let's try to solve for the constant of variation in a joint variation. Let's have example number 1. Z varies jointly as X and Y, and Z is equal to 60 when X is equal to 5 and Y equals 6. So using this given, let us try to solve for K. So first step is that we need to translate our mathematical statement into equation. Since Z varies jointly as X and Y, this statement can be written mathematically as Z is equal to KXY. So we will substitute the value of our Z, which is equal to 60, our X, which is equal to 5, and Y equals to 6 as we solve for K here. So Z is 60. Of course, we are solving for the constant of variation. X is equal to 5, while our Y is equal to 6. To simplify, let us get first the product of 5 and 6, and that is 30. times our k, so we will have 30k. Since we are solving for the constant of variation, we need to divide both sides of the equation by 30. Therefore, the constant of variation of this statement would be equal to 2. So the constant of variation will be equal to 2. Let's have our second example. X varies jointly as W, Y, and Z. If X is equal to 18, when W equals 2, Y equals 6, and Z equals 5, solve for the constant of variation. From this given statement, first thing we need to do in solving for the constant of variation is to translate our statement into equation. Since X varies jointly as W, Y, and Z, this can be written as X is equal to K, W, Y, and Z. Then, solving for K can be done by substituting our X, which is equal to 18, W, which is equal to 2, Y, which is equal to 6, and Z, which is equal to 5. So, substitute this given in our equation. So, we will have 18 is equal to K, W is 2, Y is 6, and Z is 5. Then, we will get first the product of 2, 6, and 5. So, multiplying 2 and 6, that would be 12. 12 times 5, that would be 60. So, we will have 60k. Since we are solving for the constant of variation, we need to divide both sides of the equation by 60. And k here is equal to 18 over 60. And to simplify 18 over 60, 18 and 60 has a common factor which is equal to 6. So we have 18 which is 6 times 3 and 60 which is equal to 6 times 10. So we can cancel out 6. So the simplified form would be 3/10. Therefore, the constant of variation of this given statement is 3/10. So that is now our K. This time, let's try to solve some related word problems involving joint variation. Let's have our first example. If Z varies jointly as X and Y, if Z is equal to 3 when X equals 3 and Y equals 15, find Z when X equals 6 and Y equals 9. So, solving for this word problem can be done first by translating our statement into equation. Here, in this word problem, Z varies jointly as X and Y. And this statement can be written mathematically as Z is equal to KXY. And using the first set of given, we will solve for K. And this is Z equals 3, X equals 3, and Y equals 15. This given will be used in solving for the constant of variation. So we will solve for K first. Using the first set of given, which is equal to 3. X is 3 and Y is 15. So we will simply substitute these values in our equation. So first, let us get the product of our 3 and 15. So that is 45 times K. We have 45K. Then, we need to divide both sides of the equation by 45. So we can cancel this out. So we have K, and that is 3/45. And 3/45 can be written in its simplest form, which is equal to 1/15. So 1/15 is the value of our constant of variation. So this constant of variation will be used in finding for Z when X is 6 and Y is equal to 9. So we will solve for the value of our z using our equation. Z is equal to kxy. So we will simply substitute our k, which is 1 over 15, our x, which is 6, and our y, which is equal to 9. So that is 9. Then z is equal to, let us simply multiply 1 times 6 times 9. We have 54 over 15. And to simplify 54 over 15, these two numbers have a common factor which is equal to 3. So to write 54 over 15 in its lowest term, it can be considered equal to 18 over 5. So that will be the value of our z when x is equal to 6 and y is equal to 9. So this is how to solve our word problem involving joint variation. Let's have our second word problem. D varies jointly as h and g. If D is equal to 15, when h is equal to 14 and g equals 5, find g when h is equal to 21 and d is equal to 8. So solving for this word problem, first thing we need to do is to translate our mathematical statement into equation. Since D varies jointly as h and g, it can be written mathematically as D is equal to KHG. Then, we will solve for the constant of variation using the first set of given, which is D equals 15, H is equal to 14, and G equals 5. As we substitute this given in our equation. So, D is 15, K is unknown, H is 14, and G is 5. So, first, let us multiply 14 and 5. The product of these two numbers would be 70 times k, so we have 70k. Since we are solving for the constant of variation, we will divide both sides of the equation by 70. Then, k is equal to 15 over 70. And 15 over 70 can be written in its lowest term, which is 3 over 14. Since both 15 and 70 are numbers divisible by 5. So 15 divided by 5, that would be 3. 70 divided by 5, that is 14. So 15 over 70 has its equivalent fraction 3 over 14 as the constant of variation. After we determine the constant of variation, this time we will solve for the unknown using the second set of our given, which is h equal to 21 and d which is equal to 8. So solve for g this time using again our existing equation, which is d is equal to khg. All we need to do is to substitute our d, which is 8, constant of variation, which is 3 over 14, h is 21, and our g, which is the unknown. So from this point, we can directly simplify 21 and 14, since 21 is present in the numerator and 14 is present in the denominator. So 21 and 14 are both multiples of 7. In short, this can be simplified as we divide both by 7. So 21 divided by 7, that is 3. While 14 divided by 7, that would be 2. The reason why we need to simplify this for us to engage in smaller numbers. So 3 times 3, that would be 9. So we will have our new equation, which is 8 is equal to 9 halves times g. Then, apply cross multiplication as we multiply 8 and 2 is equal to 9g. So we have 16 is equal to 9g. Since we are solving for the value of our g, we will divide both sides of the equation by 9. So therefore, our g is equal to 16 over 9. So the value of our g is equal to 16 over 9, and there is no number that can be used to simplify 16 and 9. So we will have this one as our final answer. 16 over 9 as the value of our g. So these concepts would be very essential, especially if we are dealing with joint variation. Again, if we are solving word problems that involves joint variation, the first thing we need to do is to translate our statement into equation. Second, solve for the constant of variation using the first set of given in our word problem. And third, solve for the unknown using the constant of variation and the second set of given. Hope this idea will really help you solve your concerns in answering your modules. There you have it. Hope you learned something new today. God bless us all.